Hey guys, welcome to volume day 2. Today we're going to be doing some unit conversions and we're going to be finding the volume of a partially filled container or the partial height of a container. So let's get right into it. In your notes, make sure that you have these things written down. This is just review, but write down the area formula, area equals length times width, and then write down the units that we'll be measuring in. So for area, it would be square centimeters. And for volume, it would be cubed centimeters, or whatever base unit we're using. And then, of course, write the volume formula, length times width times height. All right, let's get right into it. So since 1 liter equals 1,000 centimeters cubed, it says find the volume of water in liters in each of the following rectangular containers. Okay, so it's important for you to know that 1 centimeter cubed also equals 1 milliliter. And that's why 1,000 centimeters cubed equals 1 liter, because 1,000 milliliters equals 1 liter. So keep that in your mind. When we're finding volume of like a liquid, we'll often express that in liters, or we might be given a volume in liters, but then we'll have to convert it back to centimeters cubed so that we can find length dimensions. Okay, so for this one though, all we're going to do is find the volume. So we'll fill in our variables 20 times 22 times 12. And then we'll find the volume, which is 5,280 centimeters cubed. Okay, we're in centimeters cubed because we multiply centimeters by centimeters by centimeters. But now we need to convert that to liters. So we're going to put 5,280 centimeters cubed over 1, and then we're going to multiply it by 1 liter per 1,000 centimeters. Okay, so remember that our fraction bar can also mean per. And so remembering that will help you set up your unit corrections correctly. So when we look at that, we can see that the cubed centimeters cancel out, and then we're just going to divide 5,280 by 1,000, and we get 5.28 liters, 5 and 28 hundredths. Okay, if you need to pause the video to finish writing that, please do so. But let's move on to letter B. Okay, now in letter B, we have a partially filled container. So we want to find the volume of water in liters in this container, but notice that the water doesn't go all the way to the top of the container. So the total height of the container is 20 centimeters, but there's 5 centimeters of empty space at the top. So if we want to find the volume, we need to use this height right here, which is 20 minus 5, so 15 centimeters. So let's go ahead and fill in our variables there. We've got 10 times 30 times 15. 10 times 30 is 300. 300 times 15 is 4,500 centimeters cubed. Now we want to convert that to liters, so we're going to go ahead and set it up like that. And then we'll divide 4,500 by 1,000, and we get 4.5 liters. All right, the next one is a rectangular container measuring 20 by 20 by 22, and it's half filled with oil. And we want to find the volume of oil in liters. So there are a couple different ways we could do this. We could find the volume of the entire thing to start, and then we could divide it in 2. Or we can just divide our height in 2 right now. Since it's half full, we know that our height is only 11 centimeters. So we'll plug in that number because that's going to make it a little bit easier. So now we have 20 by 20, or 20 times 20 times 11. And our volume is going to be 400 times 11, or 4,400 centimeters cubed. And then it did ask us to find the volume in liters, so we want to go ahead and convert that. 4,400 divided by 1,000 is going to be 4.4 liters. All right, now we're going to find the height of this tank. So this tank is 90 centimeters long and 50 centimeters wide, and contains 162 liters of water when it is 2/3 full. And we want to find the height. Okay, we need to find the height in centimeters, don't we? If we're going to find the height in centimeters, we need to convert this volume to centimeters cubed. So let's go ahead and convert that. We're going to multiply 162 liters times 1,000 centimeters cubed. And we're going to end up with 162,000 centimeters cubed. Now we want to find the height. So hopefully you guys will remember how we did this the other day. When we're finding height, we're going to just still go ahead and start with our volume formula, and then we're going to plug in our numbers. So we've got 162,000 centimeters cubed equals 90 times 50. Oops, keeps wanting to change slides on me there. Okay, so we've got our numbers substituted in there. 162,000 centimeters cubed equals 90 times 50 times height. And then we want to divide both sides by 90 times 50 centimeters so that we can isolate that h by itself, that height by itself. Okay, so these cancel out right over here. And then I can go ahead and I can cross cancel with 10 here, divide both the top and bottom by 10 from that 50 and then also from the 90, so we just cross out those zeros. And I'm left with 1,620 divided by 45, which is going to equal my height. And I'm left with 36 centimeters, which gives me my height. Now, that 36 centimeters, though, is not the height of the tank, is it? It's this height right here. It's just the height of the water level. And so I want to find the height of the tank. I know that the tank is 2/3 full, and that 36 centimeters equals that 2/3. So I'm going to go ahead and use the unitary method to figure out the total height of the tank. So I've got 2/3 is going to equal 36. So 2 units is 36. We'll divide both sides by 2. 1 unit is going to be 18. And 3 units, if I multiply that out, is going to be 54. All right, next one. We have a rectangular container measuring 20 centimeters by 10 centimeters by 15, and it's 2/5 filled with water. Find the volume of the water in liters. Now, this is very much like our last problem, where we're going to use a unitary method again to figure out the volume of the water that's only partially filling up the tank. So if this rectangular container is 15 centimeters total, and it's 2/5 filled with water, let's go ahead and find the height right here so that we can use that in our formula. Okay, so we're going to go ahead and we're going to use unitary method to find the height of this container. So 5 units is 15, that's the whole height. 1 unit equals 3, so 2 units equals 6 centimeters. So now that's what we're going to use to find the volume. So let's go ahead and write our volume equation. Length times width times height, and plug in our numbers. 20 times 10 times 6, and our volume is going to equal 1,200 cubic centimeters, which is 1.2 liters. Okay, last one. A rectangular tank is 30 centimeters long and 40 centimeters wide. It contains 8.4 liters of water when it is 1/4 full. Find the height of the tank. So now we want to find the whole height of the tank. So we're going to go ahead and use our volume formula, but first what we need to do is make sure that we've got the right measurement. So it gave us our volume in liters, didn't it? We're going to need to convert that to centimeters cubed so that we can use that to find a centimeters dimension later on. All right, so there I've got my 8.4 liters times 1,000 centimeters cubed, which is going to be 8,400 centimeters cubed. And now I can go ahead and plug that into my volume formula. 8,000. All right, and so I've got 8,400 equals 30 times 40 times height. Then we're going to go ahead and divide both sides by 30 times 40 so that they cancel out over here. We can cross cancel a 10 there, and then here and here. And now I have 84 divided by 12 equals height. And if I solve that, then I get 7 centimeters equals height. Now remember though, that's only the height of the water level, okay? And it's only 1/4 full. So we're going to use unitary method, and we're going to assign 1 unit to 7 centimeters, and we're just going to multiply by 4 to find the total height. So 4 units equals 28 centimeters. Whoops. So that's going to be the total height of my tank. All right, and that is it for today. I'm drawing my little 28 centimeters there, which I don't think I can. I've been having to pause this video and try to get my pen to work this whole time. So that's why it's a little bit choppy, but hopefully you guys got the idea. We also did workbook exercise 20 in class today, so you should go ahead and do those practice problems if you were out sick today, and then come back and check your work with me tomorrow. All right, have a good night.